All right, so inverse functions part two. We're going to find the inverse of a couple of quadratic functions here. Last time we found the inverse of square root functions, and the answer was a quadratic. So here, if I'm finding the inverse of a quadratic function, I'm probably going to get a square root as my answer. All right, we're going to find the inverse and we're going to state the domain. So here we go. To find the inverse, you start by swapping the x and the y. So you get x equals 1/4 y squared. And then we're going to solve this for y. All right, before I square root both sides, I'm going to go ahead and multiply by 4. Yeah, I could divide by 1/4, but no one does that. They always multiply by 4. All right, that's going to cancel out the 1/4. And so I get y squared is equal to 4x. And then we'll take the square root of both sides. All right, square root. No, got to square root the whole thing. All right, so y is going to equal plus and minus square root of 4x. You could leave it like that. I guess because 4 is a perfect square, I'm going to go ahead and take it outside of the square root. So y is equal to plus or minus 2 root x. All right, that's my inverse. And I'm also going to state the domain. So there's two ways to state the domain here. One way is to go back to the original function and find the range, because the range of the original is going to be the domain of the inverse. And we could figure out the range of this. It's nothing too crazy. All right, there's no translation, like it's not being moved to the left or up or down or anything. So this thing's still going to start in the center, and it's just going to open up kind of slowly. That's what that 1/4 does, is it vertically compresses it. So the range of this would be 0 to infinity. All right, it starts at 0 and goes up forever. So that would mean that the domain of this is 0 to infinity. Or you could say it's x is greater than or equal to 0. So that's going to be our domain here. The other way that you could find the domain, and this is probably the better way, all right, this is a way that you should start thinking about the domain, is think about the x values that you are allowed to plug in for x. So we're not allowed to plug in any negative value into this square root right here, because that would give us something imaginary and it's not well defined. So that's another way that you could come up with the fact that x has to be greater than or equal to 0. Right? Like you can plug in 0, but you can't plug in any negatives. So that's why x has to be greater than or equal to 0. All right, there's that. Let me go ahead and show you something. There's a little bit of a thing we need to talk about here, according to this. All right, so there's my original 1/4 x squared. Now remember how this thing has a plus or minus square root of x? That's an issue. All right, so if I graph the plus and the minus version, because that is the inverse, it's that whole thing, and you see here the domain. The domain is from 0 to infinity. That's what we just found. Uh, the problem with this graph that we just found is that it is not a function. All right, this is something from back from Algebra 1. If you want to tell whether or not a graph represents a function, what you do is you start drawing vertical lines. You do the vertical line test. And if the vertical line can cross it in more than one spot, then the thing you're dealing with is not a function. Like right here, if I draw a vertical line at 20, it's going to intersect in 2 spots, and that's a bad deal. So the reason it's bad is because to be a function, every input or every x value has to go to exactly one y value. And the problem here is that 20 is spitting back 8.9, but it's also spitting back a negative 8.9. So the the quadratic function that we're dealing with here, it does have an inverse, but that inverse is not a function. That's going to be something you want to kind of keep in mind when you're talking about inverses. That's something that comes up and they ask about. But the reason that this happens, the reason that this thing fails the vertical line test, it's because the original graph fails the horizontal line test. All right. So that's actually the I guess the terminology, the test that they typically ask. They will ask you, hey, given this graph, can you tell whether the inverse is going to be a function? Well, since this thing fails the horizontal line test, that means that its inverse is going to fail the vertical line test. All right, so that's going to be the way you tell whether or not the inverse is a function, is that you see if it passes the horizontal line test. All right, like for instance, if I gave you some cubic here, y equals x cubed minus 3x, yeah, something like this. This thing fails the horizontal line test, so I guarantee its inverse is going to fail the vertical line test. See here, it's going to cross, like there's one y value here that's repeated 3 times. And so that means that on the inverse, x equals y cubed minus 3y, that means that on the inverse, there's going to be one x value that corresponds back to 3 different y values. And so this inverse right here that we just drew, or that we just graphed, is not a function. Okay, enough of that. So that's the horizontal line test. It says, if the original if the original fails the horizontal line test, then the inverse fails the vertical line test. Let me go over one more of these quadratics. All right, just finding the inverse and stuff. Y equals x squared minus 6. We're going to swap the x and the y. We need to solve for the y, so I'm going to plus 6 to both sides. And we'll square root both sides. Okay, got the square root. So I'm going to get y is equal to, and it'll be plus and minus square root of x plus 6. All right. Again, this is going to be a problem. Like the graph of this is going to end up looking something like this, where you've got the positive version of square root of x plus 6, and you've got the negative version of x plus 6 as well. All right. So this thing will end up failing that vertical line test again. All right. I guess it's always going to be true for quadratics, because every quadratic opens up like a U shape, and therefore it fails the horizontal line test. So that's always going to be the case. Yeah, that's an important thing. The inverse of every quadratic will fail the vertical line test. All right. What do I want to do here? I want to find the domain. Yeah, last bit, sorry. So the way you find the domain is you think about the values of x that you're able to plug in. All right, since you're wanting this stuff under the square root to be positive, the way you tell what x has to be is you're going to take that stuff, that x plus 6, because you want it to be positive, you're going to say this stuff has to be greater than or equal to 0. And then you're going to solve this little equation, this little inequality. Just move the 6 over. It'll be x is greater than or equal to negative 6. And this is your domain. Okay, that's going to be the domain of your inverse function. And I graphed it right here. Right, there's our x equals negative 6 part, and the graph of this thing goes to the right forever. So x is always greater than negative 6. But the idea is that you cannot take like a number that's smaller than negative 6, like negative 7, you can't plug in -7 for x because that would give you a square root of a negative. And you can't have that now, can you? All right, that's good for this one.